Hey guys, welcome to my channel. Just kidding, just math class. Okay, so we are continuing on with sequences in series, more specifically geometric sequences in series. We're going to try and make this video short enough that I don't have to cut it into two. I think we can do it. It's my closet door. Okay, so a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. So the difference between geometric and arithmetic is arithmetic we're adding and subtracting, and with geometric we're multiplying or dividing. But our R term is going to be the amount that we multiply each time, and we call it the common ratio. Okay, so if we look here, we're multiplying by 3 each time. On up. And so the way that we find our common ratio is always going to be our second term divided by our first term. Okay, in this case, I don't know why I have an equal sign there. In this case, we have our second term is 3 and our first term is 1. So we get 3 as our R value. In this next part, we're trying to determine whether sequences are geometric or arithmetic. So do we have a common ratio or do we have a common difference? Are we adding or are we multiplying? So if we have a geometric sequence, then we want to define R, and if we have an arithmetic sequence, we want to define D. Looking at our first example, I have 30, 25, 20, 15, 10, 5, 0, -5. If you didn't already notice, we are adding -5 each time. I'll put parentheses around this so you can see it a little better. So we're adding -5. So because we're adding, we have an arithmetic sequence, and our D value is going to be equal to -5. The way we can find that is by doing our second term minus our first term, if you want to show the algebra for that. All right, looking at our second example, 2, 4, 8, 16, 32, 64, 128. So we're not going up each time by adding, we are multiplying by 2 each time. If you've ever played 2048, you probably noticed that. So because we are multiplying, we get a geometric sequence. We need to find our A value. And the way we're going to do that is we're going to take our second term divided by our first term. So we get our A is 2. We already knew that because we noticed the pattern right away. I would go ahead and pause here. These next two are kind of challenging, but try and find the common difference or the common ratio between the two of them. I'm going to keep moving here for those of you that want the guidance. So we are going down. We're dividing by 2 each time. But our geometric sequence is defined by a common ratio, what we're multiplying by each time. So you can think to yourself, okay, I'm dividing, that's the same as multiplying by the reciprocal, or you can do math work. We already know it's geometric because we're dividing. What I'm going to do is I'm going to do my second term divided by my first term. 5/10 as a fraction can be simplified to 1/2, which makes sense because dividing by 1/2 is the same thing as multiplying dividing by 2 is the same thing as multiplying by 1/2. So we get that A is equal to 1/2. All right, finally, in our last example here. Our numbers seem kind of funny. I'm not noticing a pattern right away, but I'm going to go ahead and write out what we're adding each time. So from 1 to 8, I add 7. From 8 to 27, I add 19. So we're not adding the same thing every time. That's not going to work. To get from 1 to 8 by multiplying, I multiply by 8. To get from 8 to 27, I multiply by 27 over 8, which is not a pretty number. And so because I don't have either, the answer is going to be neither geometric or arithmetic. Okay, so that's how we tell the difference between arithmetic and geometric and find A. All right, moving on here, we want to find the general term. We did this with arithmetic sequences. The only difference is going to be the equation. Zoom out so you can see the whole thing here. Okay, so here's our equation. We have, for the nth term of geometric sequence, we have a sub n equals a sub 1 times r to the n minus 1. Of course, you can write that a different way. You can write it with parentheses if you want to. Note that those mean the same thing. All right, jumping into our first example, it says write the equation for the nth term of the sequence. All right, I need two things. I need a sub 1 and I need r. I don't need n because I'm looking for the nth term. So I need a sub 1 and I need r. A sub 1 is easy to find. It's just the first term. R, easy but harder. We're going to take our second term and divide by our first term. So I'm going to have 3 divided by 1. So I get 3. Okay, so because it doesn't tell us what sequence, we kind of jumped over this because we're nowhere in geometric. But if it just says find the term for the sequence, we might have to determine whether we're talking about geometric or arithmetic if it's not already given to us. So for this one, because I can see that I'm multiplying by 3 each time, I know it's geometric. So we point it out in the same way we did up above. All right, then I'll plug this stuff in. So I get a sub n equals 1 times r to the n minus 1. That right there is my nth term. All right, so the second one here, I would definitely pause here, see if you can do this one on your own. The only difference is it says find the nth term, but it also says find the 8th term. So it's a two-part problem. I'm gonna have a different color for the second part of it. All right, I need my a sub 1. It's going to be 3. And I need my r, which is 4, because we're multiplying by 4 each time. And this time it gives us the geometric sequence, so we don't have to guess on that. Then I plug in, so I get a sub n equals 3 times r to the n minus 1. So we are done with part 1 of that problem. Part 2, we need to find the 8th term. So we need to find a sub 8. 3 times 4 to the 8 minus 1, or 3 times 4 to the 7th. I don't know what 4 to the 7th is off the top of my head, so I'm going to pull up Desmos. 4, nope. 3 times 4 to the 7th. So we get 49,152 as our answer. And I forgot to put it back to the screen. All right, so we get 49,152. All right, Moving on to the next page here, if I can find it. Yep, that's right. Nope, the top. Okay, so we're finding the nth term of the geometric sequence with ace of 1 equals 4 and ace of 2 equals 20. If you feel confident doing that on your own, go ahead and pause it. If not, I'm going to keep moving along. All right, here's our equation. Ace of n equals ace of 1 times r to the n minus 1. And it says find the nth term and find the fourth term. So it's a two-part problem yet again. To find ace of n, I need ace of 1 and r. Again, it tells us it's a geometric sequence, so we don't have to guess on that. Ace of 1 is given to us. It's 4. R, we have to do our second term divided by our first term. So 20 divided by 4, which is 5. So we plug in. So we have ace of n equals 4 times 5 to the n minus 1. Part 1 is done. Part 2, find the fourth term. So n is equal to 4. Plug that in. So ace of 4 equals 4 times 5 to the 4 minus 1. Or 4, 5 to the third. If we plug that into our calculator, we should get 500. 4 times 5 to the third. And we get 500 for that answer. Could have used mental math on that, but I know a lot of you like to use a calculator, so might as well. Okay, well, that's the end. You do have an assignment tonight, so make sure you do that. Logging out. Have a great day.